Trent, stop talking. I hear you talking again. I'm going to move you to the front, yeah? We're not have the same thing as last session. That's just terrible. You all ready? Let's go. Lie down. Thank you. Now, I'm just going to go back to the skills that you learned yesterday. We learned, again, I was revising 6B, how to do cubic division, and then I taught you remainder theorem and factor theorem so that you could factorize these questions. So, just reminding you what Ian asked yesterday. Ian, phone away. I see that again, it goes in my pocket, and you're not going to take it until the end of day. Okay? No phones in my class. Now, Ian asked yesterday, he said, what if you don't have a division? So every other question you've done in 6B, they will always say a cubic division, and they'll tell you what to divide. And then what you had to do in 6B was to learn how to divide it. Now the problem is, in this question, it doesn't tell you what to divide. Your job is to find out what you need to divide first, and then you divide. Yeah? So you're going to need factor theorem, remainder theorem to know what you need to divide, and then you're going to use cubic division to divide. That's what the skill is in this exercise here. Okay, so I jumped to question 5. That's what I want you to take out from 6C. Okay, so 6C, this is the skill where you combine everything you've learned. A, B, and C goes together. Okay, so let's do the first one. We're going to do 5A. This is my equation. Now remember, you can't solve this equation because we don't know how to solve using algebra. We can't solve when you have 3 variables. The best way to do this is you want to get it into 3 brackets. That's your goal. You need to get it into 3 brackets so that you can solve it. So the question is, how do you get those 3 brackets? The first step you need to use is your factor theorem or remainder theorem to find out one of these brackets. Now remember from yesterday, how do you find out one of the first brackets? How do you figure that out again? What do you do? What's the first step? Yes, Sydney.
Do you or do you not find the factor of -1?
Fantastic. Absolutely that. The reason why you find the constant, the factors of the constant, is because remember, whatever these brackets are, you will end up with something like this. You'll end up with like x plus 1, x minus 2, or x plus 3. We don't know, okay? But what we do know is if you multiply 1 times -2 times 3, will always give you the last number. So that's why these have to be factors of that number. That's the only reason why, okay? So we don't know, so you know how like when we find the linear factors, we don't know what these numbers are. We know it's A, B, or C, right? But what we do know is that if you expand this bracket, A times B times C will eventually give you that last number. This is the only one without an X, true? So if I gave you this, if I said X plus 1 times X minus 2, right? If you multiply that, if I asked you to expand that bracket, you would have said X times X, which is X squared, and then you do X times -2, which is -2X, and you do 1 times X, which is plus 1X, and you do, finally, 1 times -2. See, that's the only number without an X.
Oh, yeah.
Now, it's the same thing with a cubic. If you have 3 brackets, it's going to be the only, or -1 is going to be the only one without an X. And so that's why A, B, or C, when you multiply these, it has to give you -1. So therefore, A, B, or C has to be a factor of -1. That's why we break up the factors. That's why we test with the last number. Okay, we don't test the other numbers. Yeah.
-1 would be -1 or 1.
Yeah, good. So you can only have 2 options there. We don't know what the numbers are, so factors of -1. Factors of -1, we can only have either 1 or -1. So that means the numbers that you're going to test can only be 1 or -1. Yeah, sometimes it could be a fraction or something like that. Yeah, so there are 3 brackets. Sometimes the 3 brackets could be x plus 1 times x plus 1 and then x minus 1. It could be like that. I have no idea. It could be that way, but we don't know. Yeah? So, here we go. Well, sometimes it could be 2x minus 1 and then 3x plus 1. So the -1 times 1 still gives you that 1, but the 3 and 2 changes the answers as well. Okay? So we don't know what the answers are. We just know the last number could be a factor of 1 or -1. So now we're going to use these factors we're going to test them because we don't know if they're factors or not. We're just guessing. We're like, maybe it's 1 or -1. So from yesterday's lesson, we're going to use factor theorem or remainder theorem. So how do you do this again? How do you use remainder theorem or factor theorem? Yes, Akita? Yeah, you sub in the value. Now, when you sub in the value, what are you looking for? What are you hoping for?
A 0.
A 0. Why do you hope for a 0? What's the reasoning?
So it's factorized perfectly.
Yes, it factorizes perfectly. Because if it has 0, it means it has 0 remainder. If it has 0 remainder, it's a nice factor. It's like 12 divided by 3. 12 divided by 3. 3 is a factor of 12. When you divide it, it has no remainder. That's why it's nice. So, here we go. We're going to test it, but we're going to say, all right, let's try if x equals to 1. Let's try to see if it actually equals 0 or not. So you sub it in, it becomes 2 times 1 cubed plus 1 squared minus 2 times 1 minus 1. That works out to be 2 plus 1 minus 2 minus 1. And yes, so happens to give you a 0. Now that you got your 0, you know that x equals 1 is a factor. What's the next step? So now you know it's a factor. How do I get it as a linear form? Because your goal was to find out the first factor. How do you do that again?
You do x minus 1.
Why is it minus 1? How do we do it again? Yes, Yasmin. Fantastic. You have currently x equals 1. That's what you know. You know that's a factor. How you want to change it to a linear factor is you remove it. Move it back. So you minus 1 on both sides. You get x minus 1 equals 0. So this is your linear factor there. That's where it goes. So what you've just done is you figured out the first factor has to be x minus 1. Now the only way for you to find out the next two brackets, what do you have to do? Yeah, that's it. So that was 6b. So what I just did with you just now is 6c. To get to the next step is 6b. 6b tells you, all right, if I take out the cubic function, which is 2x cubed plus x squared minus 2x minus 1, if I divide this by x minus 1, I should get the quadratic factors. Because you're dividing. It's like 12 divided by 4 will get you the 3. Or 12 divided by 3 will get you the 4. Yeah, or 12 divided by 6 will get you the 2. Those are all factors. So if you want to get the other factor, you simply divide it by one of the factors. That's all you're doing. Yeah? So this is where you have to use 6b, exercise 6b. So let's work this out. Let's try to work this one out. So I'm going to rub this one off. We are going to try to divide x minus 1 into 2x cubed plus x squared minus 2 times x minus 1. All right, here we go. 3 rules, or 3 steps. What were the 3 steps again? What do you do in the first step?
Find the line.
Find the line. So how do you find the line again, Finn? Fantastic. That's the first term. You're asking, what should I multiply to x to get the 2x cubed? And that would have to be, Hamish? 2x. Fantastic. 2x times the x gives me 2x cubed. But then 2x... Oh, sorry, 2x squared. Thank you. Corrected. 2x squared times x will give you 2x cubed. But don't forget, you have to multiply 2x squared to the minus 1 as well. So now you have minus 2x squared. That's find the line. What's the next step? You find the line, then you?
Subtract.
Not drop it. Subtract. Find the remainder. Find the line, find the remainder, then you drop. Yeah? So here we go. To find the remainder, you have to minus or subtract. Now to subtract both of them, let's think about it. You got 2x cubed minus 2x cubed. That gives you? 0. And then you do the same thing again. Now you say x squared minus negative 2x squared. So really you got 1 minus a negative 2. What's 1 minus negative 2? Oh, no, you're right. Oh, were you right? 1.
Yeah, negative 1. Oh no, 3.
3.
3.
Two negatives become a positive. 2 negatives become a positive. So 1 plus 2 is 3. Yeah, so 1 plus 2 is 3. So you got 3x squared. You got the remainder. Last step.
Drop it.
Drop it. So you drop the next one. Now you got minus 2x. Okay, so remember there's only 3 steps. Find the line, find the remainder, drop the value. And you do the same thing again. Just follow the same drill. I'm doing it in green, so I'm color coding it so you can see. I'm going to find the line. How do you find the line again? Something times x gives you 3x squared. What would that have to be? Can I please have Trent? What will I multiply to x to get 3x squared?
3x.
Fantastic. You got 3x. 3x times x gives you 3x squared. 3x times negative 1 is minus 3x. Subtract. See now. Found the line, find the remainder. You got to subtract it to find the remainder. So same thing again. 3x squared, take away 3x squared is 0. The only thing you have to be careful of is here. So it's x. Good. This is negative, negative becomes positive. So negative 2 plus 3 is positive 1x. So 1x. Then finally, last step. Drop it. Okay? And then you follow the same drill again. So you're saying, all right, I've got the remainder, I've dropped it, and I need to do something times x gives you 1x, and you're right, it's 1. Positive 1, so I'm going to write it up here. Positive 1, 1x, minus 1, remainder of 0, which is what you expected. Write down. This is what you expected. You had to get a 0 because you said over here that 1 was a factor. So if 1 is a factor, there should be 0 remainder. This is your quadratic factor. So how do you get the 2 brackets? What do you have to do now?
Factorize that.
Yeah, factorize this. That's your quotient. It's a quadratic equation. That's why chapter 4 was important. You've got 2x squared plus 3x plus 1. Now, using what you learnt in chapter 4, cross method, what should the 2 brackets be? Let's factorize 2x squared plus 3x plus 1. What does that become?
2 and 1.
You got 2x and got 1x, that's true. How do I get, what's the next 2 numbers? What should they be? Plus 1 plus 1. That's it. Plus 1 plus 1. Okay? You see, that's quadratics chapter. This is your bread and butter, 6b. Factor theorem and remainder theorem, 6c. Yeah, so they all tie in together. If you expand this, that's 6a. 6a is learning to expand that to check if you got the correct answer or not. But that's all it is. 6a, 6b, 6c is trying to train you to do factorization. That's it. 6d today is to solve. Remember in quadratics, to solve, you had to use null factor law. And that's exactly the same things here. See, the null factor law would tell me x equals 1, x equals negative 1, and x equals negative half. Yeah, so that's what today's exercise is about. 6D is then solving. But you can't solve if you can't factorize. You have to learn how to factorize first. Okay? Any questions on that one so far? That's what I want you to train. No?
Why does it make the negative power?
Yeah. Because I have to find the remainder. You want to find the leftover. All right. Okay, now, just before I get you to practice, I'm going to give you about 15 minutes to practice 6C. I want you to copy these 2 formulas for me. Here we go. These are called differences and sums. So sums and differences of cubes. Okay, perfect cubes. I want you to copy these 2 formulas down. They are one of the ones that most students forget. Okay, so copy this down. Trent, copy this formula down. Let's go. Will. Sorry? Yep. Please copy this down. The reason why I want you to copy this down is in your formula sheets, a lot of students will forget this, and it's one of the ones that normally comes up in your mid-year exams. Sometimes in your year 12, they sometimes throw this in. It's a very rare type of question because it takes a lot of memory to remember that. It's quite a mix of formulas there, but it is worthwhile to know for your mid-year exam. Okay, usually they chuck in one in. So I want you to copy that down in your reference book if you create one. Yeah, these two. So if you have x something cubed minus something cubed, you can factorize into that. Okay, so I want you to memorize that formula or write it down somewhere that if you do get this problem, it'll be possible to do. I'll do an example for you to see, and that's typical in your exam. Okay, so it's very typical for a cubic function to factorize. Yep. We just now say x to the power 4, but normally the function is called quartic. Yeah, it's a quartic, and then you got quintic. All right, here we go. Let's try an example. Let's have a look at this one. See, that is a typical question that you might get in your exam. Now, to factorize this, that's a cubic function, so it's not quadratic. What you can do is you can see 8x cubed plus 64. What's common about those two terms already? Both have a factor of 8. So I can take out 8, and that gives me x cubed plus 8. True? Yeah. Now you see, you've got x cubed plus 8. Now the thing is, this is very similar to this formula over here. This is x cubed plus, now if I can change that 8 to something cubed, I can use this formula to factorize it even further. So, something cubed gives you 8. 2. 2 times 2 times 2 will give you 8. So what I can say here now is I can say, all right, that's 8x cubed plus 2 cubed. Now, according to the formula, that means that's my x, a is my 2. I can use this formula here and say that must be the same thing as writing x plus 2. See, I'm just following it. X plus 2 times x squared minus 2x
plus 2 squared.
Which is 4. Okay? And this is called factorizing. Now, the last step is you want to see, can you factorize this even further? X squared minus 2x plus 4 is a quadratic. Is it possible to factorize further or not? Yeah. Sometimes you can, sometimes you can't. What numbers would you use? 2 and 2. So, was it negative 2 plus 2 or? Negative 2 plus 2 is what? That gives you minus 4.
Negative 2 plus 2.
That gives you 0.
Minus 2.
You have to complete the square.
Yeah, but then, yeah, you have to complete the square. In this case here, factors of 4, you only got 1, 4, 2, and 2. Now, out of those, there's no way you can get a negative 2. So 1 and 4, you can't get a negative 2. And 2 and 2, you can't get that. So you just leave your answer there.
Can't you do that other formula that you get 1?
Yes. But we're not trying to solve at the moment, we're trying to factorize. So that's as far as you can go. Unless you want to complete the square as well, which I don't recommend. Just leave your answer there. No, that's it. You're done. That's your one bracket, one bracket.
Yeah, but how did the right answer?
You can't. If you wanted to, you can complete the square, but that's it. That's as far as you go. Okay? You can complete the square, but otherwise just leave it like that.
Why wouldn't you complete the square?
You only complete the square to solve. But if you solve, you might as well use quadratic formula. Okay? How do we feel with that? Is that good? That's 8C. That's all of 8C. I want you to spend the next 15, 20 minutes on 8C. Okay? So that's what I want you to do. 8C. I want you to practice question 8. This is all cubic, that formulas. Okay, and I want you to factorize each of the following. So what we've just done, the first slide, formula that you were given. Formula, what you need to practice. Okay? 6C. Let's go. I'm going to time you guys. You got 11:19. Give you about... Let's go. I want you to practice that. 6B, 6C. Got to know how to divide, factor theorem, remainder theorem. Let's go, let's begin. Factor theorem, remainder theorem.
It's on.
Be like
Yeah, you just want to do it, but like I said, it's just something.
oh, those actually make sense.
You heard the door.
I don't think it's a good explanation, but it's not. I don't think it's not.
I think this is
It's a trick.
Is this just the CAD sense?
I must be used. Smash it. And then you just right. As soon as right. It's not happening. I'm taking you around for the rest of the night. Anything you try to be relationships. So I'll do it first. Come on in. I'm just saying that well, I'm not standing like we have to be reminded. Well, you need to
I want to watch it. It's still have a little bait.
Keep this out.
It probably is.
Are you gonna get it's just like sometimes my mind it's just
Push it, yeah, push it.
I think to here.
Alright, so Will, you have to leave it.
You're gonna have to write it. That's something left to do. Okay, I've got it. So the first one is minus, so I like track it all off. So anyway, it's a plus. Actually, it doesn't matter. So it's your plus, yeah. And then you just basically just replace the numbers. They really minus. Because if you're doing it, you're saying that this is that A is 1, right? It's taken by 1. And it's taken away, right? I think you hit max 5.
Why did I
See, I don't know if negative 1, if it's negative 1 I think
Are you basically telling me that he's gonna die? Then why would he not do I don't like
that's not yeah, that's
one solid oh yeah, well, you just hit the wow, I don't need that. I just want you to try to do this. You're gonna be like the remainder. How many TV lines are up? Now you want to know what the match looks like. I already want to this is one of those games. And so actually, I didn't instinct you. Yeah, perhaps the do care about stems.
So it's like it's free.
Left out something
Brains will develop.
It's gotta be like just like start just like walking around the
Yeah. It's
if it was like an hour
actually getting sorry, that's really
an hour and a half.
I'm getting
and lost him 2 hours. Like he got one back, but in the process he lost it. I say you swap speaking about
Stop talking!
like the chasing
Oh, that one.
you actually ever like?
Don't you start. Don't you start.
No, but you calculate like. So what do you think?
What, no,
Yeah, but they're really manageable. What do you think like doing is like?
It is pretty complicated.
Yeah,
It's so complicated.
I still think it's not actually that. I still don't think it's that.
No. He's overreacting. That's why
Well, I heard that Will talk about to this stuff. Will you talk about
Yeah.
That's the conversation.
Yeah.
Wow, that was so complex.
Yeah.
My brain.
I'm out. Alright, sorry, bye.
But like when you die,
So bad. What do you mean?
It's like your blame is like,
It's not a window and say that.
it's also like way
When did I ever say that?
You said that.
yeah, I mean, make me fucking say, he's like, that is my woman.
Turn up, he writes this flag on his head. Go 100. I'm not going to touch it, but no one else is allowed on this.
Yeah, I like it. That's how it is. Like, I think it's that accurate.
It's like a child. It's like, I'm not going to use it, but no one else can.
Yeah.
Even I can't, but then you can't either.
What the hell? Yeah.
I was fucking.
Yeah, but like you still like
I don't even remember saying this.
the truth comes out, and also you still like he would still and also
I thought you attended these cameras.
and also I was like you would have been so
I learned how to divide.
What's that splash?
they were like it's okay.
That's called the splash. So like movies,
I don't think she is.
like the splash. It's like this is.
I don't think so. She's kind of like, oh, okay. That's, I guess, nice. But you find
Like you splash something.
I got angry about the hour.
you just be a little bit down.
No, you just be a bit like, oh my
I just heard like everybody likes the
well, everyone is doing the same. Even to where I live,
I
thought it was
and then I'm just like, fuck. were gonna get married.
What did I ever say?
You said it.
Yeah, I can
Not the marriage.
What you fucking mean?
No, you didn't say you get married. You said you were looking so
When did I say that? When?
But like you said,
flying off the big chase.
you said like I you said it was
Wait.
Would you follow you?
Oh, that's evidence. That's clearly completely What, so everything I say,
How do you do H though?
so I'm gay for H. I said I'm not H.
I am the real one.
Yes. This is month I haven't said that. This was like 2 weeks ago.
Really?
No, you said
Yeah, like you said.
I'm back. Will, how'd you go?
I got this from my these two.
we did nothing.
Tell me the truth. Hurry up. I helped two people in there.
I got here and I just got
Yeah, that's what I like about that scene as well. Yeah, but like, yeah, where are they? Yeah, you can hear it from the first leaving it like he gets burnt down as well. So I know what he's trying. Sort of. That was a solid reference. It was a solid reference. What if I would have so like, I do like to the light so one's called and it was like, well, yeah, and then she gave the space to now. So it was very exciting.
Your someone said it was supposed to be mind if they had maybe makes it that's the second thing you want to see that t-shirt. I wouldn't mind doubt he's reinstalled. I wouldn't mind it. Why? It's just like that ain't right. You don't see it on the screen.
Like, I don't know.
Let's play with Yeah, they spring with those. Yeah, apparently you use one of these. You probably see. That's the only it's like a knight in armor, also a table.
Oh, wait. Yeah, instead of putting things on it.
And just I like David. Oh yeah, David.
See you Thursday. I mean, I'll have you tomorrow. Alright, thank you.
What's the
Everyone.
See you.
Who 16 tomorrow?
I mean, I can say much like 16. Oh, that's really cool. Interesting ways that I've never seen.
See you, Will.
Like,
Picnic boys. See ya.
special.